Okay. Welcome, dear children. We are going to start our 2020 level English medium physics class. So, how are you? I think you all are prepared for this now. Okay. Let's start. For our subject, we need three books. We need three books. I think it's better to have CR books, not these small books. Take these CR books. That's good. And I will update you when you need to buy them. First, we can go through a single book. Okay, use a single CR book for first 2-3 weeks. Then I'll inform you when to buy the new books. Okay. So shall we start now? Okay. Now write our first topic, physics. Okay. Our first topic is physics. Let's write it. Our first topic is physics. Okay. So, what is the meaning of physics? So I'm starting. I'm starting the class now. Okay. So what is the meaning of physics? To start our subject, I'm asking you a question, Puta. So what is the meaning of physics? What do you mean by physics? The first thing, what do you mean by physics? What is the meaning of physics? How we say? What is the meaning of physics? Actually, shall I say it like this? Physics is understanding the nature. Physics is understanding the nature through the man-made models using some theorems and equations. Physics is the understanding of the nature by man-made models. For these models, theorems are used, equations are used, and there's a mathematical background. So this is the thing. Shall we write it first? Then one by one, I'll explain it to you. Okay? Let's write it. So our first topic is physics. So our first topic is physics. Under physics, let's write it. Physics is the our first topic is physics, children. Physics. Okay. Physics is the understanding of the nature. Physics is the understanding of the nature. Physics is the understanding of the nature by man-made models. Physics is the understanding of the nature by man-made models. For these models, theorems, equations, and other mathematical elements are used. Okay. Yeah. So in our first day, my first topic is the meaning of physics. Physics is the understanding of the nature through man-made models. When these models are used, we have to use theorems, equations, and other mathematical elements to handle these models. Shall I give you an example to explain this? Shall I give you an example? Okay, come. Now, Puta, okay. Now we all know our Earth. Orbits around Sun. I'm giving you an example to show you what physics is. This example is to show you what physics is. Okay. Now you all know our Earth rotates around Sun. So it's the nature. Our Earth is rotating around the Sun. So it's the nature. Earth rotates around sun. So nature is that earth rotates around sun. So can you remember the scientist who explained this? There were many, but can you remember the chief person among them? There were many people trying to explain this rotational motion of earth around the sun. Meantime, can you remember the most respected one, Newton? What he said? He said, all these earth, sun, and all these other planets and suns, they are governed by these gravitational theorems. So let's say this like this. To explain how the earth rotates around sun, Newton made theory of gravitation. We can use Newton's theory of gravitation to explain this. So what is the man-made model? So the nature is that sun is here and earth is rotating around it. To explain this thing, that earth's rotation around sun, the nature, we use a man-made model. What is that model? Gravitation. What is that model? Gravitation. Okay. So physics is understanding the nature through man-made models. So there's a man-made model called gravitation. We can use that gravitational theories to explain and understand how the earth rotates around sun. In the gravitation, they say earth is attracted toward sun by a gravitational force which is equal to G m1 m2 over r square. I'll explain them later. I'm just giving you an example. I'll explain these things later in the correct lessons. But here now I'm just getting an example. No need to worry about these things. Just listen and look at the board. Okay. So the nature is the earth rotating around sun. To explain that, what happened? Newton gave the model gravitational fields, gravitation, whatever. Okay. In that model, we have equations. And through these equations, many things are explained. Earth has a tangential velocity. And it has an angular velocity. Meantime, the gravitational force is acting, and sun is having a mass m1, earth is having a mass m2. Likewise, now the story goes. Okay, now I'll come to the point what I need. I don't need to teach you these gravitational theories now. I just want to show you something. Physics is understanding the nature through man-made models. So in the nature, there's a phenomenon called earth rotates around sun. There's a man-made model called gravitation to understand the situation. That's physics. That's what I want to say. Okay, write a small star mark. For this example, write a small star mark. In nature, earth rotates around sun. Earth rotates around sun. To explain this, man-made model of gravitation can be used. So this is physics. Explaining the nature through man-made models. Okay, can you draw this? I need you to draw this force, symbolize these masses for something. To show you something, I need you to draw this thing fully. Now the earth is rotating around sun. Sun. Mass of the sun is m1. Mass of the earth is m2. And there's a gravitational force F. Just write them. I don't need these exact things to be taught to you today. I'm just doing something, something nice. Okay, just write them. M1, M2, and when rotating around sun, there's a angular velocity omega. There's an angular velocity omega for Earth, and there's a tangential velocity 2, and there's a gravitational force towards sun, this gravitational force is equal to G m1 m2, mass of earth, mass of sun, and R is the, don't worry, yeah? Just write R square, just write R square, don't worry. Okay. Now Puta. Okay. Physics is the understanding of the nature through man-made models. I took an example, Earth's rotation around sun. It's a natural thing, it's in the nature. To explain this thing, as physicists, what we have to do? We have to use the model of gravitational. Okay, in the model of gravitation, now listen to me carefully. In the model of gravitation, to explain this thing, what we have? Equations. We have equations. That's what I want to tell you. We have equations. Okay, and equations means we have to do some mathematical activities there. That's how the physics goes. That's what I want to show you. Okay, and the most important thing, when I'm explaining it to you, when I'm explaining these things to you, I'm using some words. I'm using some words. Force. Now I told you there's a gravitational force. So I'm using the word force. Then I told you that there's a tangential velocity. I told you that there's a tangential velocity. So I have used the word velocity, the velocity word. Then I told you inside this equation, the mass of Earth and mass of Sun is introduced. So mass, words are there. This is my point now. I don't need you to teach the gravitation today. This is what I want to say. To understand the nature, we have man-made models. Using man-made models to understand the nature is physics. So we are doing physics. Inside physics, we meet theorems, we meet equations, mathematics, and we are handling this. And most importantly, we meet some words: gravitational force, tangential velocity, mass of Earth, mass. So Puta, I want to tell you, what are these words? What are these words? Force, velocity, mass. What are these words? These words are called physical quantities. These words are called physical quantities. These words are called physical quantities. Write it. Write it. These words are called physical quantities. Force, velocity, mass. Force, velocity, mass. These words are called physical quantities. These words are called physical quantities. Okay, physical quantities. Okay, keep it in mind. Now I introduced the word physical quantity. Physical quantity, keep it in your mind. Okay. Let's go to our next example. Students, I'm not teaching you these theories. I'm not teaching gravitation here. I want to bring up this word, physical quantity. Force, velocity, mass, these are called physical quantities. That's what I want to point out. Okay, let's go to the next example. Let's go to the next example. Okay. So what is physics? What is physics? Physics is the understanding of the nature through man-made models. Okay, this is my second example. Okay, this is my example number 2. There's a person. This person is talking. There's a person. This person is talking. And there's another person. There's another person. He hears. he hears what he say. There's a person, he's talking, and this person can hear. Isn't this the nature? This is nature. In nature, when someone talks, other people can hear. This is nature. So, what is the man-made models to understand this nature in physics? In nature, there's a very simple thing. When someone talks, other people can hear. It's the nature. Now, I told you that physics is explaining the nature through man-made models. So, what is the man-made model to explain this? When someone talks, other people can hear. What is the man-made model to explain this? What is the man-made model to explain this? Sound waves. Sound waves. We can't see sound waves. We can't see sound waves. It's a man-made model. We say when someone talks, there's a sound wave moving. And this sound wave will enter the other person's ears. And he will listen to that. He will get it. He will get the voice. Okay. So the nature. So the nature is, let's write it. Let's write it together with me. Draw the picture. Someone is talking and other person can hear. So the situation in the phenomenon in the nature. When someone talking, others hear. When someone talking, others hear. Okay. So what is the man-made model to explain this? What is the man-made model to explain this? Sound waves. What is the man-made model to explain this? Sound waves. That's what I'm telling to you. That's what I'm trying to tell you. Physics is the understanding of the nature using man-made models. Now, when someone talks, other people can hear. It's a natural thing. And man-made model to explain this is sound waves. Sound waves. And we draw a sound wave and we explain this thing. Okay. When explaining this natural phenomenon using sound waves, what are these special words we use? What are these special words we use when explaining the sound waves? What are these special words we use? We don't need these O-level parts. I'm teaching you all of them. I'm just taking examples from O-level. I will teach you all these things when the right lesson comes. I'm just taking examples. Okay. So what are the words we use when we are handling the sound waves? Sound velocity, and then wavelength, just write them. Wavelength. What are the equations? Velocity is equal to f lambda, where f is the frequency. Now you meet many more words when explaining these phenomena. Can you see? Nature is when someone talks, other people hear. Model to explain this is sound waves. When we are dealing with sound waves, when we are in the man-made model sound waves, we have equations. V equals f lambda and many more. And the most important thing, we meet new words. Velocity, wavelength, frequency. These new words are called physical quantities. Write them. These new words are called physical quantities. These new words are called physical quantities. These new words are called physical quantities. Now, Puta, I have given you two examples. Now, tell me, what is the physical quantity? When we explain the nature through man-made models. It's called physics. When we are doing physics, we get equations, theorems, many more. And the best thing, the most probable thing, we meet some new words: force, velocity, mass, frequency, wavelength. I told you these are physical quantities. Now, can you give me a better explanation? So what is a physical quantity? Now we are doing physics, and when we are doing physics, we meet these physical quantities. So what is a physical quantity? So what is a physical quantity? Shall I say it like this? Physical quantity is a property in the nature that we pay our attention in order to explain things. Physical quantity is a property in the nature that we use in our model to explain. Okay, shall we write it then? Now I have given you 2 examples. After these 2 examples, write it down as a small star mark here. As a small star mark, write it, Puta. Write it. Force, we'll mention them. Force, mass, time, force, mass, time, velocity, frequency, and there are many more words. We meet when we are doing physics. They are called physical quantities. Physical quantities are the, write it up. Physical quantities are the properties in nature. Physical quantities are the properties in nature that we use to build our physics models. Okay, that we use to build our physics models. Okay. So, children, we are doing physics now. Physics is the understanding of the nature through the man-made models. There we will meet equations, theorems, mathematical elements, many more. By them, we explain nature. When we explain nature using these physical quantities, we meet a large number of words: force, mass, time, frequency, wavelength. Okay, many more: displacement, velocity, acceleration. These words, they are called physical quantities. So what are physical quantities? Physical quantities are the properties of nature that we use to explain our physics models, to do physics. Okay, right. Now I told you physical quantity is a property in nature. I'm pointing out some good thing. I'm pointing out a very important thing. Listen to me carefully. Physical quantity is a property in the nature, as I said. As your teacher said, now a physical quantity is a property in the nature. A physical quantity is a property in the nature. Shall I tell you another property in the nature? Tell me whether it's a physical quantity or not. In nature, the red color is there. In nature, red color is there. Red color is here. I'm wearing. In nature, red color is a very good thing. Red color is a property of the nature. So, is this red color a physical quantity? Think. Is this red color a physical quantity? Think it. In nature, there's a sensation called hunger. in nature, there's a sensation called hunger. We feel hungry, hunger. It's a property of the nature. All the animals feel that. Is it a physical quantity? Hunger, is it a physical quantity? Sometimes we feel sorrow. It's in nature. It's a property of nature, sorrow, sorrowfulness. Sometimes we feel happy. We feel happy. It's a property of nature. All the people feel that time to time. So is it a physical quantity? Think. Velocity, mass, time, acceleration, they are physical quantities. Okay? But these feelings, sorrowfulness, happiness, colors, red color, blue color, they are not physical quantities. Do you know why? Do you know why? If it is a physical quantity, it should have a unit to measure. If it is a physical quantity, in physics, we should have a unit to measure it. For force, we have newtons. Okay? For time, we have seconds. But for hunger, do we have an exact way to measure it? To measure hunger, do we have a method? No. To measure color, do we have a method, a unit? 5 kilos of red, 10 seconds of red. No, we don't have a unit. Write down that. The next star mark, in physics, the property to be considered exactly as a physical quantity, in physics, the property to be considered as a physical quantity, in physics, the property to be considered as a physical quantity there should be a exact unit. There should be a exact unit. There should be a exact unit to give the value of it. There should be a exact unit to give the value of it. There should be a exact unit to give the value of it. To give the value of it. So, sensations, feelings. So, sensations. Like hunger, happiness. So, sensations like hunger, happiness, colors. These type of things are not physical quantities. These type of things are not physical quantities. These type of things are not physical quantities. Okay? Okay. Now we know something. We have started. Physics is understanding the nature through man-made models. When we are doing physics, we meet equations and theorems and many more mathematical elements, especially some words, many more words. And these words are generally called physical quantities. But to be a physical quantity, a unit is essential to measure it. Force from newtons, mass from kilograms. Okay, they are physical quantities. But when you come to these sensations like hunger, happiness, we don't have units. Colors, we don't have units, so they are not physical quantities, even though they are properties of nature. Properties of nature with a well-established unit are known as a physical quantity then. Okay, we are here now. Okay. Now, so what is the nature of a physical quantity? A force with 5 newtons value. So in a physical quantity, can you see that? If we say a force, 5 newtons, velocity, 2 meters per second, acceleration, 3 meters per square second, mass, 8 kilograms. So a physical quantity always contains a numerical value to give its magnitude, as well as a unit to explain how it measures. So if it is a physical quantity in our lesson, in our physics, it has a numerical value to give the magnitude and a well-established unit to explain it. So shall we write it? Okay, the next star mark. So in a physical quantity, there is a numerical value. So in a physical quantity, there is a numerical value to explain its magnitude, to explain its size, 5 newtons. To explain its magnitude, so in a physical quantity, there's a numerical value to explain its magnitude, and a unit to explain how it is measured. 5 newtons, 5 millinewtons, let's see. And a unit to explain how it is measured. And a unit to explain how it is measured. And you need to explain how it is measured. Okay. Now we know what physics is, and we know that we meet physical quantities and units when we are doing physics. Okay, children, can you suggest me a topic for our first lesson? I was doing a general explanation about our subject. Okay. Now, can you suggest me the topic of the first lesson? By looking at the explanation I did to you, by hearing the things I have told to you, can you guess what will be our first topic in our syllabus? Now we are going to do physics by the things that I have discussed with you. Can you guess a topic for our first lesson? Can you guess a topic for our first lesson? Physical quantities and units. That's how it goes. This is not O level. We are not starting from the point that you have stopped from somewhere in the middle. We are starting from the beginning of the subject. So what's the next topic? Physical quantities and units. When we are doing physics, we meet physical quantities and units. So let's try to understand them. Okay, write first unit. Okay, we'll write it in a nice manner. First unit number 1. Right, unit number 1, physical quantities and units. Unit number 1, physical quantities and units. Unit number 1, physical quantities and units. Okay. Okay, physical quantities and units. Okay, Puta, this is how it goes. Okay, children, this is how it goes. Okay, now in our syllabus, initially it gives a brief explanation what physics is and how these things run. Then it comes to its first unit, physical quantities and units. Okay, let's start it. physical quantities and units. Okay. Now, physical quantities and units. So this is how it starts. I told you A levels start from the beginning. So let's pay our attention for the older days. What were the initial physical quantities that man tries to understand? Was it current and electricity? No, it was something newer. Was it angular velocity of an electron around a proton? No, these are later things. What were the earliest physical quantities man paid his attention? Time, mass, length. These were the most oldest three physical quantities that man paid the attention. From the beginning of the civilization, people understood that there's something called time. These flows and things happen, there's something called time. And there's something called mass, the amount of matter. It was understandable, amount of matter. And length, there's a length, the distance. It was also one of oldest physical quantities that people understood. Try to understand. Okay. Physical quantities and units. Under that, write the first Roman number. Mass, length, and time. Mass, length, and time were the oldest physical quantities. That people understood, that people tried to understand. I don't think that they understood time correctly. But let's say like this. Mass, length, and time were the three oldest physical quantities that man tried to understand. Mass, time, and length. Let's write down. Especially for length, there are many older units. Especially for length, there are many older units that we have used. Okay. So our first unit is physical quantities and units. As I have told you many times, our A-level syllabus start from the beginning. So I went to the beginning. Mass, time, length, these were the oldest physical quantities people try to understand. Especially the length. It's a reasonable one. Time, even though they try to understand it, it's somewhat difficult. No? Time, what's actually time is, we know that time flows. But understanding time, what means time, it's a difficult thing. No? Even though we feel that. But especially the length, the distance between 2 points, it's understandable. That was the beginning. In the civilization, there are many older units. Brought up to understand the length. So can you tell me, what are these older units to understand the physical quantity called length? So can you tell me, number 1 is correct. So can you tell me, what are the older units that explain the length? To understand the physical quantity length, what were the units that we have used earlier to understand length? Do you know something called handspan? This thing, Handspan. Handspan. Okay. This handspan. Handspan. Do you know something called cubit? Cubit. Length of this size. Cubit. Now we are in our first lesson, physical quantities and units. We are going to the beginning of the civilization to bring these things from there. Okay, the older units, all the physical quantities that we have paid our attention is mass, length and type. Among them, length is the most acceptable, understandable one. So we are paying our attention to some of the older physical quantities that we have used to measure length. Okay, let's draw them to measure length. In the same Roman number, let's draw them to measure length. We use handspan. Then the cubit. You need these words, huh? Cubit. Remember these words. I'm not saying that these will come to exam. When we are starting a syllabus, if the things we are taught you in first day, if they are coming to exam, it's not exam. Exam will be created from the later lessons. These are for your understanding about the subject. But remember this. This is a handspan. This is a cubit. This is a cubit. Okay. This is a cubit. Okay. Then, Puta, these are called body-based units. Write that word also. Body-based units. Body-based units. Body-based units. Okay, body-based units. Okay. What else? What else? I'm explaining to you what were the earliest attempts, what were the earliest units that we used to measure length. What were the earliest units? Handspan, cubit. Have you heard something called shouting distance? These were the oldest units. Have you heard something called shouting distance? If someone shouts, the distance that it can be heard is the shouting distance. It's not a body-based unit. It's not a part in the body, but it's also one of earliest method to understand the length. Shouting distance. Write that too. Shouting distance. Shouting distance. There are many more. These were the older methods, older units that we used to measure the length. Okay. No need to write, just listen. To measure mass, there are some stones that they have used. Say this measuring mass is important when these older people doing their grain business. Some people harvest grain and they have to sell them. When selling grains, to take that exact amount, they have to measure the mass. To measure that mass, those vendors those days have had some stones, some nice stones. Mass of the stone is used as the unit, and from that mass of stones, one parcel of grain is 2 times that of the stone. Likewise, there were many types of stones used in older days to measure mass. The reference will be the mass of that stone. Say there's a grain packet, it's 2 times mass of that stone. There's another grain packet, it's 3 times mass of that stone. Likewise, huh? Okay. I'm not going to write them. I'm just giving you an idea. Okay. Now, with this idea, can you tell me, so what are the inaccuracies? What are the inaccuracies in these kind of units? To measure length using hand span, to measure length using cubit or the shouting distance, to measure mass using the special stones. What are the inaccuracies of these methods? What are the inaccuracies of these methods? What are the inaccuracies? These type of units change from person to person. These type of units change from person to person. Okay? When one person when one person takes its hand span, it's not same as the other person's hand span. This change. Okay, let's write that thing. Huh? That's what we need to pay our attention. Why all the units were rejected. That's the point we need. Okay. That's the next Roman number. Let's write them. The inaccuracies of these units. Huh? Let's write them. The third Roman number. These older units are inaccurate. 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 Let's continue writing. From person to person, hand span change, no? Shouting distance change. From person to person, from person to person, from place to place, let's write. From person to person, from place to place, from place to place, from time era to time era, from time era to time era. These units are changing. These units are changing. And once, write it, and once, this kind of a measurement is vanished. And once this kind of a measurement is vanished, and once this kind of a measurement is vanished, you can't build it again. And once this kind of a measurement is vanished, you can't build it again. You can't build it again. You can't build it again. Did you understand what I said? Did you understand what I said from the last sentence? Now I have introduced you some older units, especially some older units to measure length. And then I have shown you the inaccuracy of them. What are the inaccuracies? They change from person to person. Hand span change from person to person. They change from time era to time era. The same person, when he was a child, hand span is a smaller one. When he becomes a elder, hand span is a larger one. So it changes time era to time era. These are not accurate units. Okay, and it changed from location to location. Here in Sri Lanka, when we shout, most probably it will travel more. But in a very cold country, when we shout, that sound will not, most probably, there are many factors, most probably that sound will not travel that much. Most probably, there are many factors. I'm just explaining the normal things. Okay, in Sri Lanka, when we shout, most probably sound will move a higher distance. But when it's in a low temperature country, sound won't move that much. Okay, so it changed from location. So shouting distance is not an accurate unit. It changes with the location. Okay, hand span is not accurate unit. So these are rejected. Okay, So these were rejected. And when something rejects, a new thing comes, a better thing comes in science. When a certain thing is rejected in science, it's always replaced. It's always replaced by a new thing, a new, better thing. That's happened all the time. But children, especially in 18th century, there were two replacements for the older unit systems. When older units are rejected due to their inaccuracy, always time to time, not the 18th century, always time to time, new unit systems are built up to ensure that they are better than the older ones. But there's a special case. In 18th century, there were two new good unit systems were brought to world. One is British imperial system. One is British imperial system, a set of new good units, and the other is CGS, centimeter gram second, CGS unit system. British imperial system in 1824 and CGS system in 1874. Okay, they were some good set of innovations. Huh? Okay, next Roman number. So I'm explaining you how this physical quantities and unit lesson came to the today's time. How these older units are replaced and what were the important things in the middle of the journey. Likewise, we are coming to the subject from step by step. This is how the syllabus goes. Huh? Okay. Okay. Now write the next Roman number. Write the next Roman number. While rejecting all the inaccurate units, 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 new units were built up. New units were built up with better qualities, with better qualities, with better qualities. In 18th century, in 18th century, in 18th century, British imperial unit system. In 18th century, British imperial unit system. British imperial unit system. British unit system. British unit system and CGS unit system. And CGS unit system. And CGS unit system were introduced. 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 Okay. Now write them like this. British unit system in 1824 and CGS unit system in 1874. 1874. Okay. Write them. And here I'm going to give you the basic units that they have used under this unit systems. Huh? Okay. Okay. Puta, are you feeling better? Is it understandable? I'm a father of 4 children. Nah? Puta, I'm a children. I'm a father to 4 children. I have 3 daughters and a son. Okay, I'm not that much older. I'm not that much older. But Puta, I did my. I was born in January. Yeah, I was born in January. So I faced A level 1 year earlier. I was born in January, so I faced A level 1 year earlier, and I got selected to the university from the first try. And I got selected to the university from the first try. Okay, and there I I had my degree. It contains 4 years, a 4 years degree, a physics special degree. But when to take the degree, it takes 5 years. As soon as I get out from the university, and I married, I had my wedding. Okay, so I'm not that much older, but still I'm a father for 4 children. Nah? I'm a father for 4 children. I have 3 daughters and a son. So I can feel the children. So what's the situation now? What's the situation now? Are you okay with the teachings? Can you understand well? Okay. If you like, you can keep me a message. If you feel that teach us like in the same way you have taught us today, or sir, can you add these new? You can suggest me things. Keep us a message. This normal number that we are in, that I'm representing my WhatsApp group. It's not my personal number. It belongs to one of our members in the team. But still, they forward me those kind of messages. Okay, so I will receive them. Okay, so you can keep a message. Okay, or YouTube comment or whatever. Tell me whether you understand these things, or if you're feeling better, you get the subject. Give me your suggestions. Huh? Okay, and okay, and my hobby is also teaching. I like to teach. Okay, so when I'm at home, I'm teaching my own children too. Huh? When I'm at home, even though they are small, the elder son is in grade 5, still I'm teaching all of them. Okay, so this is my life. Okay, so keep a comment if you have some suggestions. So you teach us like this, teacher like this. Likewise, if you have suggestions, tell me. Yeah, okay, leave me a message for this our normal number in the group. This number ending up with 31. You can leave a message, and even though it's not with me, okay, the appropriate messages will be forwarded to me. Okay, so I get your message. Yeah? I get your message. Okay, shall we continue then? Shall we continue? Oh, I will give you another 2-3 minutes time. Go. Drink some water, refresh yourself, and come. Okay. Now what's the time? It's 8:30. Okay, I'll start teaching again at 8:35. Huh? I'll start teaching again at 8:35. Go drink some water, refresh yourself, and come. We'll start teaching at 8:35. Okay. We are start teaching again at 8:35. Meantime, if you have some messages, at the moment the number is with me, so you can keep a message or you can leave a YouTube comment. Okay, whatever, and get ready. I'm going to teach you again at 8:35. Now it's 8:31. Nah? Okay, we are going to start. I'll give you another interval. I'll give you another small break. I'll give you another small break later. Shall we start now? Shall we start? So shall we start now? Okay, our members are logging in again. So shall we start? Remember, education is the best thing that can ever happen to someone. Nah? Okay, write it somewhere in your book. Education is the best thing that can ever happen to someone. Education is the best thing that can ever happen to someone. Okay, remember that. In my life, the most precocious thing I have in my life is my education. Okay, I have many things in my life. I have a certain amount of money with me. I have my family, I have my 4 children, and I have some valuable things with me. But still, the best thing ever happened to me is my education. That's how I feel it. Okay, that's how I feel it. So the education is the best thing that can happen to someone. Okay, so you are in your you are very lucky now. So you are very lucky now. You have started A level science. Just see around you. How many of you got the chance to do science subjects now? Go through your memory. How many friends didn't get the chance to start these science subjects? So you are very lucky. So remember, you have to finish this. You have to finish this with the university entrance. Huh? You have to finish this with the university entrance. Don't get satisfied unless that. Okay, don't get satisfied before that for some lower point. Definitely you have to select for the university. I'm trying my best from this subject, and you have other 2 subjects to balance the subjects and do them from the first day. Balance the subjects and do them from the first day. I will give you many other very important guidances through our journey. No, or I don't have time to guide you all through these things today. I have to teach you, but still, while teaching, I'll give you some very good guidance, okay, throughout our journey. And you have 3 subjects. Pay your attention to each and every subject equally. Pay your attention to each and every subject equally. That's a must. That's a must. You need 3 A passes. You need 3 A passes. One is having A pass, the favorite subject, and other 2 subjects are having S passes. That won't do the work. That won't do the work. So allocate time equally for these 3 subjects. There are no favorite subject and unwanted subject. All subjects should be your favorites. Okay, keep that in your mind and allocate time equally and do your work well. Now at the beginning of the syllabuses, you don't have, at the beginning of the syllabi, plural of syllabus is syllabi, no? At the beginning of the syllabi, you don't have many things to study. You will have enough leisure time in between the classes. Still, school is also not there now. So you will have enough time in between the classes. Okay, take your leisure time. Spend leisurely. But when you are doing your work, but when you are doing your education, when you are in classes, when you are studying them, when you are going through them at home, do them correctly. Do them efficiently. Okay, finish all of them. Don't leave them half done. Okay, complete them. These are the methods. Okay, let's start teaching again. Let's start learning again, and let's get this target. We need 3 A passes, and let's take a pass for physics. When you have a pass for physics, how happy will you know? How happy? How proud will you? Okay, so remember that. Definitely try your best to get a pass. Let's try. You can. You can. Okay, and the initial thing I told, education is the best thing. Education is the best thing that can ever happen to someone. Okay. Okay, so let's start. Shall we start now? Okay, let's start. Now, okay. Here, shall I brief you the things? Shall I brief you the things that I have taught up to now? Shall I brief you the things that I have taught up to now? I'm going to brief the things. Okay, listen. Now, these are the things. Physics is the understanding of the nature through man-made models. Physics is understanding of the nature through man-made models. To do this, to handle these man-made models, we get theorems, equations, and mathematical work, many more things. Okay, I gave you 2 examples. When sun is when Earth is rotating around Sun, it's something in the nature. It's explained by the man-made model gravitational fields. And this gravitational fields is the physics behind that, the method to explain. For that, we have these equations and many more things. When someone talks, the next example we took, when someone talks, other people can listen to it, other people can hear it. So to explain this natural phenomenon, we use sound waves. Sound waves is the man-made model to understand the nature there. Okay, in sound waves or the gravitation or whatever the situation, when explaining these models, we get physical quantities: force, velocity, mass, acceleration, time, many more. A physical quantity is a property of nature that we use to explain these things. A physical quantity is a property of nature that we use to explain these things. Okay, but in physics, especially, it becomes a physical quantity not only it has a not only when it becomes a property of nature, but also it should have a unit. Physical quantity is something, a physical quantity is a property of nature. Not only that, it should have a unit to measure. Newtons, joule, likewise. Okay, so take it briefly. Let's say a physical quantity, a 5 Newton force. So what it contains? It contains a magnitude, 5 Newtons, 5, a numerical value to explain the magnitude, and the unit behind it to explain how it's measured. 5 Newton force, 2 meters per second velocity, 8 seconds time, likewise. Oh, yes, these are the things we learned generally. Then we understood to go through physics, the best place to start is to understand these physical quantities, as they are commonly used in everywhere. Understand these physical quantities. So our topic of the first unit 1, the topic was physical quantities and their units. Physical quantities and their units. Under that, we went to the beginning of civilization to take roots from there. Length, mass, time are the oldest physical quantities that people has tried to understand. Among them, length is the oldest. Length is the physical quantity that they have given some units. They have given units most, because length is somewhat understandable with respect to time. Okay, mass is also there. Mass is measured from these stone type things in old days, and the length, it was measured from hand spans, cubits, okay, then shouting distances, likewise. But these units are inaccurate. They change from person to person, time era to time era, location to location, and once it is vanished, we can't create it again. Say someone is shouting, then he will have a shouting distance. But what will happen if he is having a cough? If he is having a trouble in his mouth, he can't shout like that again. The next time he shouts, we can't guarantee that sound will travel the same distance again. It changes. Once it vanished, we can't build it again. So these are not accurate units. Okay. So when something is felt to be inaccurate, there's always a replacement in science with a good one. That's how it goes. Okay. So always there are new replacement of new units which are better than the older ones. Especially in 18th century, 2 sets of good unit systems were introduced to the world. One was in 1824, British Imperial Units, British Unit System. And the other was CGS Unit System. And the other was CGS Unit System. Okay. Now, in British Unit System, mass was measured by pounds. Okay. Then length measured by feet, not only feet, miles, there were many more methods, pounds, ounces, likewise. I'm not writing all of them, you don't need to remember, you have to have the idea. Okay, then in British unit system, mass was measured by pounds, ounces, many more. And the length was measured by feet, inches, feet, inches, miles, many more. Okay. And volume by gallons. Have you heard that word? Gallon. Gallons. Okay. Gallons. Likewise. Time. Puta, if you dive deep into this British unit system, there was no any special unit introduced for time. But those days, minutes were popular. So it's okay to say minutes. But remember that, you can have a Google search. But remember that when this British unit system was introduced, there's no any specified newer unit to measure time. As there was time, these minutes always there. In that era, we can say minutes. No one will blame us. But still, remember that there was no any special unit to measure time introduced newly through the British unit system to measure time. These are the facts. Okay, somehow, so this is the British unit system. Pound and ounces, likewise, to measure the mass. And to measure the length, feet, miles, inches. To measure the volume, gallons. To measure the time, minutes. Okay. Now come to CGS system. Okay. After I point out these things, you can write them. Puta, in CGS system, what is C? To measure length, centimeters. C is denoting centimeters. To measure length, centimeters. To measure mass, grams, G. Grams. Then to measure time, seconds. Okay. These are the methods in these two good systems with respect to older unit systems. These are two very good systems introduced in 18th century. British unit system and CGH unit system. Can you write these things? In British system, to measure mass, pounds and many things, length, feet, inches, miles, volume, gallon, time, minute, let's say minutes. Here to measure length in CGS system, centimeter, gram, seconds. Length is measured by centimeters, C. Mass is measured by grams, G. Time is measured by seconds. Okay. This was developed in France. This was developed in France, and this was developed in British, UK. This was developed in England, and this was developed in France. Write these things, and especially these units are used for day-to-day work. These units are used to day-to-day work, while these were for scientific researchers. These were for scientific researchers. Okay. Now, can you see, especially the CGS system? Inside the CGS system, time is measured by seconds. Still, we use seconds. It's a very good unit. And still in our school, we have this feet. We are using ruler. It measures the distance from one side you have centimeters, other side it has inches and the feet. Okay. So these British units or these CGS units are not rejected. They are not bad. But why we are not using them now. Now we use meters, and to measure length we use meters, to measure time still we use seconds, and to measure mass we use kilograms. What are they? To measure temperature we use Kelvin. What are they? And why these two type of good units are replaced by these newer ones called SI? I will give you the word SI. What is these SI units? Why were they brought up? Even though we have this good unit system of units. This is the case. Now these unit systems, British Imperial one and the CGS unit system, they are not bad ones. They are not bad ones. Okay, they are not bad ones. But when the different parts of the world use different unit systems, it's very disturbing. It's very disturbing when different parts of the world using different unit systems. It's a very disturbing thing. When we share our knowledge with the other part of the world, when we doing business, when sharing scientific work, when it goes to education, child from a certain country moves to another country for his higher education. But in that country, they use a different set of units. He will feel crazy. No? So it's not good. So scientists thought all these things should brought into a single unit system. All the world should brought into a single international unit system. That's why these were rejected. These are not bad units, but using different units in different countries makes things difficult. So they were rejected and new set of single units valid throughout the world was introduced. Still they are in use. But we have a better one. This new set. Okay, we'll finish this thing. Write the next Roman number here. Write the next Roman number. Write the next Roman number. Write the next Roman number. These are not bad unit systems. 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 But these are not bad unit systems. But using different unit systems in different places, but using different unit systems, in different countries makes the things difficult. Makes the things difficult. Makes the things difficult. Makes the things difficult. When doing business, and when sharing knowledge, it is confusing. It is confusing. It is confusing. It is confusing. So scientists introduced this new unit system. So the scientist introduced this new unit system called Standard International. Called Standard International. Called Standard International, within brackets SI. Within brackets SI. which is common to all the world, which is common to all the world, which is common to all the world, which is common to all the world. Okay. So this is the next thing. This is the next thing, the next developing story, the SI unit system. In old days, especially before 18th century, there were many unit systems and they were very much inaccurate, not accurate, very much inaccurate. So they were replaced time to time. And especially in 18th century, they were replaced by two set of good unit systems, British and CGS. They are not bad. Still, we have them in our use. But still, when sharing knowledge and doing business, it confuses. When separate parts of the world use separate system of units. So it was brought to a single unit system, Standard International, SI, in 1960s. Okay. Now write the next subtopic, Standard International SI units. The next subtopic, Standard International SI units. This is the next subtopic, Standard International SI units. Okay. Next subtopic, International Standard SI units. SI units. Okay. Okay. Puta, now the most important thing in today's lesson, okay, you don't need to study these things. You have to have the idea. This is the first day. The things today, the general facts, they will not be asked in your exam, but to build up what is inside physics, to take the correct direction in physics, you need these facts. How it came, how it was developed, what happened. These things are important in that point of view. Okay. Now, what is our point? Even though the British system and the CGS system are good, still they were replaced by a single unit system common to the world. And it's easy to work now. Okay. And I want to tell you this thing. These SI units, Standard International SI units, were brought to arena in 1960s. In 1960s, the best thing, the best revolution, best finding, the highest level of physics is the Albert Einstein's relativity. Albert Einstein's relativity. Actually, relativity was also over. It was already found. It was already established when it comes to 1960s. So this SI unit establishment was done after many breakthroughs of science. Now, as this SI unit system is newer, as this SI unit system is newer than many breakthroughs of science, this SI unit system has the touch of all these new concepts. So it's a very good one. It's a very advanced one. Why? It was newer. It was built. It was assembled after the most of the important findings in the world. Even Albert Einstein's relativity was also established before the establishment of SI units. So can you understand that? It's a very newer one. It has all these good touch from these heavier theories. So it's a very accurate one. It was brought to arena in 1960s. As it's a very accurate one and it's a very broad one. There are many sections in SI unit system. Base units, derived units, prefixes, how these units are transformed, what are the substantial units. There are many kind of categories inside this SI unit system, and through all these categories, you can have a good idea of physics. Physics is run on this base. in this SI unit system now. Earlier it was running through the, especially through the CGS unit system, but now the physics is running on this SI unit system. Okay, so our next aim is to understand the SI unit system well. So our next aim is to understand the SI unit system well. It will help us to fill the foundation of physics. Okay, so I'm going to understand the SI unit system. I'm going to teach you the facts in the SI unit system. As I have told you, it's a very broad one. It has many subsections. I will take one by one. Okay, first subsection, base physical quantities. Base physical. Write it with me. Base physical quantities and their units. 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 So in SI units, it's a very broad one and it covers complete physics subject. It's a very nice one. Okay, there you have base units, derived units, prefixes. I will teach you all. In our syllabus, we have to teach you all these parts, all these categories under SI unit system. Actually, it's the first lesson. It's the core of the first lesson. Units and physical quantities and units. It's our first lesson. We know that. So inside this lesson, core is to understand standard international SI units, and it will give us a good base to do physics. That's how the things go here. Okay. Now we are in our first subcategory under SI unit system, base physical quantities and their units. Children, what are base physical quantities? 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 Okay, I'll explain to you what a base physical quantity means. But before that, I will write them. And it's easy for me to explain. Okay. Remember, there are 7 base physical quantities. There are 7 base physical quantities. After writing these 7 quantities, I will explain you what a base physical quantity means. Okay. Length. Length is a base physical quantity. Time. Time. Mass. Mass. Thermodynamic temperature. Length, time, mass, thermodynamic temperature. Electric current. Electric current. Amount of substance. Amount of substance. Luminous intensity. Luminous intensity. Shall we write them first? When you are writing them, when you are writing these 7 base physical quantities, you have to write them in the left side of your book. You have to write them in the left side of your book. You have to write them in the left side of your book. Then here you have to fill some 2 other columns too. Here you have to fill some 2 other columns too. Okay, so leave the right side. In SI units, our next main aim, core of this first unit is to understand the SI unit system. Why? It gives us a good foundation to do our physics. Okay. Earlier physics was done mostly in CGS unit system, but now it's based on SI unit system. In SI unit system, there are many subcategories. Among them, the first subcategory is base physical quantities and base units. I haven't explained what a base physical quantity yet, but still I have told you there are 7 base physical quantities, and these are the 7 base physical quantities, and I asked you to write them. Length, time, mass, thermodynamic temperature, electric current, amount of substance, and luminous intensity. Length, time, mass, thermodynamic temperature, electric current, amount of substance, luminous intensity. Okay. Here, what is this luminous intensity? What is this luminous intensity? Luminous intensity is the bright. I'm not telling you the exact definition. I'm giving you an idea. We are in the first day. For all these parts, we have lessons to come up. We have lessons to face. Inside these lessons, all these things we taught again and again. Okay. I'm just giving you the idea, Puta. Okay. So give me an idea. What is luminous intensity? What is luminous intensity? Luminous, simply take it, it's the brightness. If I switch off some lights here, brightness will be lower. If I switch on all the lights around me, I will have a better brightness. Luminous intensity is high. Luminous intensity, it's something about brightness. What is amount of substance? Just have idea. What is amount of substance? Amount of substance is special. Amount of substance is special. Say, whatever the substance, it talks about the amount. It's a special one. Amount of substance. Whatever the substance, it talks about the amount. Say you are having balls. Substance is balls. When you have 2 balls, you can say it a pair. Pair. When you have 12 balls, you can tell it you can gather it as a dozen. Okay, dozen. So amount of substance. Amount of substance means it's not specified for certain substance, balls or stones or molecules, whatever the substance. Here we are talking about the amount. Amount. If it's 2 from same item, pair. If it is 12 from same item, dozen. Likewise, amount of substance is measured. There's a SI unit. I'll tell you when the right time comes. Okay. So these are the 7 base physical quantities: length, time, mass, thermodynamic temperature, electric current, amount of substance, luminous intensity. Okay. And to measure length, the SI unit is meter. Shall we fill these columns first? Then we'll discuss. Okay. To measure length, SI unit is meter. And symbol is simple M. And symbol is simple M. To measure length, unit is meter and symbol is simple M. Symbol is simple M. Okay. To measure time, unit is seconds in SI. In SI, unit is seconds, symbol simple S. Symbol simple S. To measure mass, unit is kilograms. Write it with me. Unit is kilograms. Symbol kg. Symbol kg. To measure the thermodynamic temperature, unit is Kelvin. Kelvin is a name of a scientist. So it's capital K here and here also. For the kilograms, K is simple. Okay. And here K is capital. Okay, Kelvin. To measure the thermodynamic temperature, it's Kelvins, capital K, the SI unit. To measure electric current, it's ampere. It's also a name of a scientist. So the symbol is capital A. So the symbol is capital A. Ampere. And amount of substance. Okay. Now we'll explain amount of substance a little. Amount of substance. Okay. Now leave these two parts to be filled and come to the bottom. I need a star mark. Note down with a star mark. Amount of substance. Here I'm giving you a small briefing about amount of substance. Write a small star mark. Amount of substance is not specified for a certain substance. Amount of substance is not specified for a certain substance. Amount of substance is not specified for a certain substance. It's different. It gives us an idea. It gives us an idea about the amount we select from that substance. The amount we select from that substance. If we select 2 from that substance, let's say we select 2 balls. If we select 2 from that substance, we select 2 balls. If we select 2 from that substance, it's a pair. If we select 12 from that substance, it's a dozen. Is a D, no? It's a dozen. If we select 12 from that substance, it's a dozen. Likewise, if we select Likewise, if we select 6022, likewise, if we select 6022 and write another 20 zeros, 20 zeros. Likewise, if we select 6022 and add another 20 zeros, within brackets 6.022 10 to the power 23 in scientific numbering. 6.022 10 to the power 23. Likewise, if we select 6022 and 20 zeros, that means 6.022 10 to the power 23 units from a substance from a substance, it's a mole. It's a mole. It's a mole. It's a mole, and it is the it's a mole. Okay, it's a mole, and it is the SI unit, and it is the SI unit, and it is the SI units. It is the SI unit to measure the amount of substance, and it is the SI unit to measure the amount of substance, and it is the SI unit to measure the amount of substance. Just write it. I'm going to explain it again. I'm going to explain it again. I'm going to explain it again. Okay. Calm down. Now listen to me again. You will meet these things in the appropriate lessons. You will meet these things in the appropriate lesson, but still we'll try to understand them. We'll try through them. We'll go through them. Okay. Okay. Now listen again. Now listen again. Here there are 7 base quantities, and it said that there are 7 base units. Among them, I was explaining to you about the amount of substance. There are 7 base quantities which are having 7 base units. We are under SI units. Our new attention is to understand the SI units. When we understand in the SI units, there are many subcategories that we have to understand. First subcategory is the base units. It is told that there are 7 base units. They are length, time, mass, thermodynamic temperature, electric current, amount of substance, and the luminous intensity. You have heard these: length, time, mass, thermodynamic temperature, electric current. You have at least heard them. We'll go to the appropriate lessons. At least you have heard them. Luminous intensity, it's the, just assume, just take it as the brightness. Okay. What is this amount of substance? I'm trying to explain it to you. Now we are trying to understand it. Amount of substance. Amount of substance is special. Amount of substance is special. It's not specified for a certain object. It's not specified for a certain object. Sometimes this amount might be balls. Sometimes this amount might be cats. Sometimes this amount might be number of electrons. Sometimes this amount might be gas molecules inside the room. Whatever the amount, whatever the substance, here in this physical quantity, it's different. Here in this physical quantity, we talk about the amount. Whatever the substance, here we talk about the amount. Now, say you have 2 balls. You can say a pair of balls. A pair. 2 is known as a pair. The amount 2 can be known as a pair. Say you have 12 plates. It's known as a dozen of plates. So whatever the substance, plates or balls, if it's having a 12, number of units are 12, it's said to be a dozen. Likewise, if you have 6, 0, 2, 2 and 20 zeros behind that, 6, 0, 2, 2 and 20 zeros behind that, that amount is known as a mole, and it is the SI unit to measure the amount of substance. That unit is a mole. 6022 and 20 zeros. 6.022 10 to the power 23. Whatever the substance, that much of amount, 6.022 into 10 to the power 23, is known as a mole, and it is the SI unit to measure the amount of substance. Okay, can you tell me why this size of a large number is introduced as the SI unit? Can you tell me why this amount of a very large number is introduced as our SI unit? Because this moles are used to measure, to calculate the number of electrons, subatomic particles, protons, gas molecules are the beneficiaries. We use this concept mole to measure them. There are billions, trillions of gas molecules inside the small room. So we can't have idea about them without this much of a larger portion, a mole, 6.22 into 10 to the power 23, likewise a part. Okay, so in that kind of calculations, moles are generally used. So amount of substance, whatever the substance, amount of substance stands for the amount that it contains. Pair, dozen, likewise the SI unit is mole. A mole is, a 1 mole is equal to 6.022 into 10 to the power 23 amount of items from that certain thing. Okay, so here amount of substance is measured by mole, MOLE, and here MOL. Okay, and about the luminous intensity. It is about the luminous intensity. Let's write it, children. The SI unit is candela. About the luminous intensity, the SI unit is candela. The symbol is CD. About the luminous intensity, SI unit is candela, and it is CD. About the luminous intensity, SI unit is candela, and it is CD. Okay, I will tell you something. Now a 1 candela roughly equal to the brightness gained by a 1 candle. Not the exact value, 1 candela roughly gives you the amount of light given by a candle. Okay, it's just a rough idea. Okay, 1 candela roughly gives you the amount of light, brightness that's given from a single candela. Luminous intensity is measured by candelas, CD. So now we are learning these SI units. When we are learning these SI units, there are many categories. The first category is the base units and base physical quantities and their units. Under SI units, first semi-category is base physical quantities and their units. And now there are 7 base physical quantities. And 7 SI units to measure them, and you have 7 symbols. Now tell me, what is the specialty of this base unit? How can you explain to someone what is a base unit? What is the method that they have followed? To define a base unit? What do you mean by a base unit? I will give you another small interval. So no need to run away. You have to get used to this now. Okay, I will give you a small interval after a short while. Okay, so listen to me carefully now. So how a base physical quantity can be defined? Yeah, you have 7 base physical quantities. And how to define that? What do you mean by a base physical quantity? Remember, children, a base physical quantity is a physical quantity that the 7 base physical quantities are the physical quantities that are independent from one another. 7 base physical quantities are the physical quantities that are independent from one another. To explain mass, you don't need time. Mass is independent from time. To explain electric current, you don't need mass. Electric current is independent from mass. To explain luminous intensity, you don't need meters, length. They are independent. So, throughout physics, scientists moved throughout all the branches of physics, and they got these 7 physical quantities that are independent from one another. There are no 8, there are no 9, only 7. Throughout the physics, these are the only physical quantities, only 7 physical quantities which are independent from one another. So these independent physical quantities which are independent from one another are known as base physical quantities. To explain mass, you don't need length. To explain amount of substance, you don't need time. They are independent. Okay, write a small star mark down here. Write a small star mark down here. These 7 base physical quantities, these 7 base physical quantities, these 7 base physical quantities, these 7 base physical quantities are these 7 base physical quantities are the ones who are independent from one another, are the ones who are independent from one another, are the ones who are independent from one another. To explain a certain quantity, we don't need to use, to explain a certain quantity, we don't need to use other quantities. To explain a certain quantity, we don't need to use other quantities when it comes to base quantities, when it comes to base quantities, when it comes to base quantities, when it comes to base quantities. When it comes to base quantities. Okay, this is the thing. Now, the next thing. Okay, now sir, are you going to do the complete 3 hours today? No, I'm not going to do that. Okay, you are just after your O-levels and it's the first day and you are in front of a screen. Okay, so I'm not going to do complete 3 hours today. We'll have plenty of time, and there in the next classes we can increase our time too, or we can divide this class into 2 days. One day for 2 hours and another day for another 2 hours. Then altogether we'll get 4 hours. That's very good. And it will be easy for you to handle also, as it is divided. Okay, let's discuss these things. Somehow we need to have a good result. That's the main aim. Okay, so we'll discuss all these things and we'll manage it. Okay, today I'm not going to complete all 3 hours. It might be difficult for you. Okay, we'll manage it. Some days we might be doing 3 hours. Sometimes we might be doing the class 2 weeks a day, one day 2 hours, the other day 2 hours, and it's easy to manage the 2 hour time. And altogether within the week, we'll be doing 4 hours. Then likewise, we'll handle it. Okay. Now, before finishing, I thought of giving an interval also, but I think best way is not to conduct the full 3 hours as it's the first day and I was completely teaching to you. I didn't give any other instructions, although I was just teaching. So I'm not going to complete all the 3 hours today. But before stopping it, I have to come to a certain point. Okay, before stopping the lesson, I have to come to a certain point. So let's listen. Let's do this and let's complete up to the correct point. Okay, let's continue. Now I was telling you about base physical quantities. Now I was telling you about base physical quantities. There are 7 base physical quantities and there are 7 SI units to measure them. And these base physical quantities are the quantities which are independent from one another. To explain mass, you don't need time. To explain ampere, current, you don't need mass. Likewise, they are the independent 7 quantities in physics world. I'll explain it to you like this. Take force. Later in mechanics lesson, we will learn about the force. I'm just taking the example. Take force. Force is equal to mass into acceleration. Force is equal to mass into acceleration. Force is equal to mass into acceleration. So mass, what is acceleration from your O-level knowledge? Velocity over time. Velocity over time. So force is equal to mass into velocity over time. What will happen next? What is velocity? Velocity is displacement over time. Velocity is displacement over time. So what is force now? We will learn these things later, but still I'm taking example. Force is equal to mass into acceleration, mass into velocity over time. Velocity is displacement over time. Velocity is replaced by displacement over time, and you have another time here. Time. So force is equal to mass displacement and time square here. So what can you see now? Even though force is a very popular physical quantity, can you see? It is affected by many base quantities. That's the difference. When it comes to a base quantity, it is not affected by anything. It's independent. But when you come to the other quantities, then these 7 base quantities, they are affected by these base quantities. They are not independent. They are affected by one or more than one base quantities. Now I think you get a better understanding about a base quantity. There are 7 base quantities in physics and there are 7 SI base units given to measure them. This is the first category under SI unit system. Okay, and to explain you about the base physical quantities, I came up with this non-base physical quantity. This is not a base physical quantity. Later we will say this is a derived physical quantity. Next day we will say that this is a derived physical quantity. So this is the thing. When it comes to a derived physical quantity or non-base physical quantity, up to our knowledge, up to our present case, let's say take force. Force is equal to mass into acceleration. Acceleration, velocity over time. Velocity, displacement over time. So finally force ends with mass into displacement divided by time square. So can you see force is affected by these base quantities, time, length and mass. So it's not an independent one. Inside it, there are effect from mass, time and displacement. Displacement means a length. So that's the case. If it comes to a base quantity, it will not act like that. Okay. Can you write that example also? write that example with a star mark, when it comes to a non-base quantity, 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 inside it, there are one or more base quantities. There are one or more base quantities included. There are one or more base quantities included. Base quantities included. Okay, then write this. Okay, so right from the bottom, so these type of physical quantities within brackets force. So these type of physical quantities. So these type of physical quantities within brackets force are categorized under derived, D-E-R-I-V-E-D, are categorized under derived, D-E-R-I-V-E-D, are categorized under derived physical quantities, are categorized under derived physical quantities, and they have the influence, from base quantities, they are not independent like base quantities. They are not independent like base quantities. Okay, they are not independent like base quantities. Okay. So next week our lesson is about derived physical quantities. So next week, are you happy? No, next week our lesson is about derived physical quantities. I'm not going to take a class within this week, but eventually with time I'll be taking more classes, and we have to do work. You can't say no, you have to do more work. Okay, I'll be assigning them in the correct order. Okay, so these are the things. Next week we'll start with the derived physical quantities. Okay, and go through the lesson carefully, read it again and again for 2-3 times. Try to take the idea. Don't study any of these things, these numbers or anything. If it is needed, there's a lesson coming from behind that it is explained more than this. I'm just giving you the idea as it's the first lesson. Okay, this is how the first lesson goes in the syllabus. It's just giving you an idea and a briefing and a direction to continue a subject. Okay, that's the thing. So to read it 2-3 times, go through it carefully, and always hope that you are going to have a pass. Feel that victory inside you. Okay, and live a good life. Be okay. Now we are in your after O-levels time, so spend it happily, and let's meet next week. And important updates will be given to you through the group, and I will upload this video to the group for the children who missed the part. And from the next week, we will be continuing the lesson through our Pahan Hettiarachchi.lk website. I'll inform you these things inside the group. Okay. So if you have any suggestions, you can keep a message for this command number, 331 number at the end, and my team will pass the message to me if it's a important one. Okay, or if something about adding to the group or whatever the thing, they will handle it. If it's an important one, they will pass it to me. Okay, so best of luck for your A levels. Okay, let's meet next week. Good night.